Okay, they give us polynomial functions and they want us to work out their degrees. You get the degrees by counting up how many roots you've got and what their multiplicities are. So here at point A, we have a root, it touches the x-axis, and the fact that it comes up, touches the axis, and then turns away means we have multiplicity 2 or 4 or 6, something like that. Then we have a straight crossing point at D, which has to be multiplicity 1, and we have a crossing at F, which is also multiplicity 1. So in theory, there's an infinite number of degrees this curve could have, but they told us use the lowest possible degree, so don't use 4 or 6 or anything like that. Go with the lowest multiplicity you can get away with. So the lowest total we could have is 2 plus 1 plus 1, which would make this curve of degree 4. Now for points which represent real and equal roots, we've got, at point A we have 2 roots which are the same. That's what multiplicity 2 means. D is a single root, so that doesn't count, and F doesn't count either. So point A is the only one where we have real equal roots, the same number happening, in this case, 2 times. For our next curve, we have a root at P, and we have a root at S. And for it to come down in this way and curve like it's going to turn back, but then curve again and continue through the axis, that's called an inflection point, or an S-bend. That multiplicity would have to be 3 or 5 or 7, etc. And at S, the same thing happens. 3 or 5 or 7, what have you. So the lowest possible total for our degree here is 6. The lowest this could possibly be is degree 6. And real equal roots, well, those happen in both cases. We get 3 real equal roots at point P and 3 more at point S.